The machines that learn. Imagine you open Netflix, and before you even search, it already knows what you might want to watch. You open YouTube, and somehow, the next video feels like it was chosen just for you. A bank detects a suspicious transaction before you even realize something is wrong. A self-driving car recognizes a pedestrian in a fraction of a second. An AI assistant understand your question and give you an answer. But here's the question: who teaches machines how to do all of this? Not just software engineers, not just data scientists. There is another role, standing directly between data, artificial intelligence, and real-world systems. They're called machine learning engineers, and their job isn't simply to build a machine learning model. The real challenge is making that model actually work at scale in the real world. Because building a model inside a notebook is one thing, putting that model in front of millions of users is something completely different. And that's where the real engineering begins. But here's what makes this career is fascinating. A machine learning engineer can start with basic programming and eventually become a principal ML engineer, an ML architect, or even a head of AI and machine learning. And along the way, the skills become more advanced, the problems become bigger, the systems become more complex, and the earning potential can become extraordinary. So how does someone go from writing their first Python program to build AI systems used by millions of people? Then that we're breaking down every level of a machine learning engineer's career, from a beginner to the very top. Let's begin. Level 1, the beginner. Every machine learning engineer starts somewhere, and surprisingly, it doesn't begin with artificial intelligence. It begins with fundamentals, programming, mathematics, statistics, algorithms, and problem solving. Your first challenge isn't building a self-driving car. It's understanding how computers actually think. You learn Python. You learn how data structures work. You study algorithms. You begin exploring probability and statistics. And eventually, you discover that changes everything. A computer doesn't always need to be explicitly told what to do. It can be learned patterns from data. That simple idea is the foundation of machine learning. At first, the concepts feel difficult. Linear regression, classification, decision trees, neural networks, training data, testing data, loss functions, optimization. It can feel I like learning an entirely new language. But then, something happens. You train your first model. You give it data. You let it learn. And suddenly, it makes a prediction. It's not perfect. It makes mistakes. But I learn something from the data. And that's the moment you realize you're not just writing software anymore. You're teaching a machine how to recognize patterns. In this, it is only the beginning. Level 2, Junior Machine Learning Engineer. Your first model works. But there's a problem. It only works on your laptop. And that's not enough. Because companies don't need models that worked once. They need models that work every second for thousands or millions of users. That's when you discover The difference between machine learning and machine learning engineering. Now, you have to take your model and turn it into a real system. You learn how to write clean code, how to build APIs, how to connect machine learning models with software applications. You start working with databases, cloud platforms, containers, and version control. You learn how to package your model so another application can actually use it. Imagine a shopping website that predicts what product a customer might buy. Your model can't just sit inside a notebook. It has to be received real customer data, make a prediction, and return that prediction in milliseconds. That means your model has to become part of the product. And suddenly, you're no longer just training algorithms. You're engineering an entire pipeline. You start understanding why models fail, why does data change, why predictions become inaccurate, and why a model that was excellent last month can become useless. That's when you encounter one of the biggest challenges in machine learning: model drift. The world changes, customers change, markets change, human behavior changes, and your data changes with it. So your model has to evolve too. Junior machine learning engineers can earn roughly $100,000 to $150,000 per year, depending on experience, location, and company. But now, you're ready for something bigger. Level 3 Machine Learning Engineer. After gaining experience, you begin working on real production systems. Now, your models are no longer experiments. They're products. A recommendation engine might influence millions of users. A fraud detection system could analyze thousands of transactions every second. A computer vision system could process millions of images. And suddenly, your decisions have consequences. A small improvement in model accuracy can generate millions of dollars in additional revenue. A tiny mistake can do the opposite. This is where engineering becomes just as important as machine learning. You learn how to optimize models, reduce inference time, manage massive data sets, build reliable pipelines, and deploy models across the cloud. You work with Python, SQL, TensorFlow, PyTorch, Docker, Kubernetes, cloud infrastructure, and increasingly, large language models. You begin understanding something critical. The best machine learning model isn't it always the most complicated one. Sometimes, a simpler model that is faster, cheaper, and easier to maintain is the better choice. Because in production, performance matters, reliability matters, cost matters, and speed can matter even more. Now, you're becoming the person who can take an idea from research all the way to reality. And that's what companies really pay for. At this level, machine learning engineers can earn roughly $140,000 to $220,000 per year. But the next level changes the scale completely. Level 4 Senior Machine Learning Engineer. Now, you're no longer just building systems. You're designing them. Junior engineers come to you when their models fail. Software engineers ask how to integrate AI into their applications. Data scientists need your help, turning experiments into production systems, and engineering leaders want your opinion before investing millions of dollars into an AI project. Your responsibility has changed. You think about architecture, scalability, reliability, security, cost, and long-term performance. You might design a recommendation system that serves millions of people, or an AI platform that supports hundreds of internal teams. The challenge is no longer, can we build it? The question becomes, can we build it reliably at a massive scale? You start designing distributed machine learning systems, automated training pipelines, real-time inference platforms, feature stores, model monitoring systems, and AI infrastructure that other engineers can build on top of. And then, a new technology. It begins changing the entire industry. Generative AI, large language models, AI agents, multimodal systems. Suddenly, machine learning engineers are working on systems that I can understand text, images, audio, video, and even complex instructions. The possibilities become enormous, but so do the challenges, because building a powerful AI model is one thing, making it safe, reliable, affordable, and useful is another. Senior machine learning engineers can reach $200,000 to $300,000 plus per year, especially at major technology companies. But there's still a level above, where you're no longer just building AI systems. You're deciding how entire AI platforms should be designed. And that's where the principal machine learning engineer entered the picture. Level 5, principal machine learning engineer. At this level, something changes. You're no longer measured by how much code you write. You're measured by how much impact you create. A principal machine learning engineer look at the entire system, not just one model, not just one team, the entire AI architecture. You decide which technologies should be used, which models should be built, which systems should be redesigned, and sometimes which projects shouldn't be built at all, because experience teaches you something important. Not every problem I need AI, and not every AI problem needs the biggest model. Sometimes the smartest engineering decision is knowing what not to build. You work closely with data scientists, software engineers, data engineers, cloud architects, product managers, security teams, and executives. Our decisions can influence the architecture of entire AI platforms. Imagine a company with millions of users wanting to introduce AI-powered recommendations. You aren't simply building the recommendation model. You're designing the infrastructure that allows hundreds of models to operate across the company. You're thinking about training costs, inference costs, latency, data pipelines, model monitoring, security, privacy, scalability, and reliability. At this level, your technical decisions can save millions of dollars or cost millions. Principal machine learning engineers can earn $250,000 to $400,000 plus per year, with compensation potentially going much higher at major technology companies. But there's another transition ahead, because eventually, you're not just designing AI systems, you're deciding the direction of the entire AI organization. Level 6, Head of Machine Learning/AI. Now, your role becomes much bigger. You're responsible for people, technology, strategy, and results. Multiple machine learning teams may report into your organization. Research teams, engineering teams, ML platform teams, AI product teams, and infrastructure teams. All I need, a common direction. Your job is to create that direction. You decide where the company should invest its AI resources. Should it build its own models? Should it use existing foundation models? Should it develop AI agents? Should I invest in computer vision, natural language processing, recommendation systems, or something completely new? These aren't purely technical questions. They are business decisions, and the stakes can be enormous. A successful AI strategy can create a completely new product, transform customer experience, reduce operational costs, or open an entirely new market. But a bad strategy can waste millions of dollars and years of development. That's why leadership matters. At this level, you spend less time writing code and more time building teams, evaluating technology, working with executives, and deciding what the company should do next. Compensation can reach $300,000 to $500,000 plus per year, depending on the company, experience, location, and equity. But there are still very few people who reaches the absolute top. Level 7, Chief AI Officer/VP of AI. At the highest level, you aren't simply managing machine learning. You are helping define the company's entire AI future. Your decisions can influence thousands of employees, millions of customers, and potentially billions of dollars in business value. You sit at the executive table. You discuss AI strategy, business growth, risk, security, privacy, innovation, and the future of the company. You ask questions that most engineers never have to ask. How should AI transform our business? Where should we invest over the next 5 years? How do we compete against companies building faster AI systems? How do we use AI responsibly? And most importantly, how do we turn artificial intelligence into sustainable business value? At this level, your technical knowledge still matters, but your vision matters even more. Compensation at the highest executive levels can reach $500,000 to $1 million plus per year. At some companies, especially when bonuses and equity are included. But here's a real lesson. The journey from a beginner to an AI executive wasn't built in one day. It happened one skill at a time, one project at a time, one failed model at a time, one difficult problem at a time, And every machine learning engineer who reaches the top started exactly where you could start today, with curiosity, a laptop, and the willingness to learn a real lesson. But here's what most people don't understand about machine learning. The technology will keep changing. The tools will change. The models will change. The programming languages will evolve. Today's most powerful AI system could become tomorrow's old technology. But one thing will never change: the ability to solve problems, to think critically, to understand data, to learn new technologies, and to build systems that actually create value. That's what makes a great machine learning engineer. Not memorizing every framework, not chasing every new AI trend, but understanding the fundamentals daily enough to adapt to whatever comes next. Because the future won't belong to the people who knows one AI tool. It will belong to the people who knows how to learn the next one. Final career journey. Think about where is this journey can take you. You could start as a beginner, learning Python in your bedroom, then become a junior ML engineer, building your first production models. A machine learning engineer, deploying AI systems used by thousands or millions of people. A senior engineer, designing scalable AI infrastructure. A principal engineer, defining the architecture for entire AI platforms. The head of machine learning, leading teams and shaping AI strategy. And eventually, you could reach the executive level, where you're no longer just building AI. You're deciding how AI will shape the future of an entire organization. That's the journey, not a shortcut, not an overnight success. A progression built through the builds, experience, curiosity, and consistency. Now, I have a question for you. If you could choose only one, which career would you choose? Robot face machine learning engineer, bar chart data scientist, cloud engineer, laptop computer software engineer, shield cybersecurity expert, or something completely different? Tell me in the comments. And don't just write about your career. Tell me why. Because your answer could become the inspiration for our next documentary. If you enjoyed this video, hit the like button, subscribe to Career Theory, and turn on notifications, because every week we break down the careers building the future, from a beginner to experts, from my first salary to the executive level. No shortcuts, no hype, just the real career journey. That is Career Theory. And remember, you don't need to know everything to get started. You only need to start learning the first thing. We'll see you in the next documentary. Until then, keep learning, keep building, and keep thinking about the future. Because one day, the technology you're learning today could be the technology that changes the world tomorrow.